So now that I've talked about what a non-concurrent collector is, let's talk about how you might implement such a class or such an interface. And as you'll see in our discussion, I'm going to show you how to do this for sequential streams, and we'll talk about each of those 5 methods you see here on the slide. The collector interface itself is a generic interface that defines 3 generic types. So if you take a look at the documentation, you can see it has 3 generic parameters, T, A, and R. And T is the type of object or elements that are available in the stream. So it could be long, could be string, could it be search results, could be a list of search results. There's a bunch of different things you can have as T. A is the type of mutable accumulator object for a collection. So, for example, if you're going to be having a list of something, like a list of strings or a list of objects or a list of search records or whatever, then it would be list of T, where T is the actual type that was defined as the first generic parameter. And this can be implemented by an array list, a linked list, or whatever. Lots of different things you can have for collectors. Lists are pretty typical. And then the final parameter is the type of the final result, which is often, in some cases, many cases, the same as the accumulator type. In fact, sometimes they're one and the same, and we'll talk about that when we talk about what finishers do. But it doesn't have to be the same type. It could be the same type. It's often the same type. So given those 3 parameters, then there are 5 methods in the collector interface that have to be defined. And again, I'm going to be talking here solely about non-concurrent collectors. We'll talk about concurrent collectors later. So one of the methods is called characteristics. And this basically provides the streams framework with metadata or additional information that's used for internal optimizations and semantics. And so, for example, the 3 different characteristics you can have is whether something's ordered or unordered. And if something is unordered, that means the collector is free to order the results in any way it seems most optimized for the collector implementation. So it doesn't have to order things in any particular way. If you don't set unordered, then it assumes that it should be in so-called encounter order. And a collector can also order things in encounter order if it's easy to do. So for lots of things like, for example, for arrays, putting things in encounter order is pretty straightforward. It doesn't mean sorted. It just means in the order in which the elements in the stream were encountered in the first place. The second property is called identity finish. And what this means is after we're done accumulating and combining everything, is the end result the same as the last item that was put into the mutable result container? And if the answer is yes, if the finisher method is essentially a no-op, then if you set the identity finish characteristic, it says don't bother calling the finisher. It's not going to make any difference. Just take the result at the end when all the elements are processed and just return it as the result of the collector. So if you set identity finish, that means it's an indication to the framework, don't call the finisher method. And then the third and final characteristic is concurrent. And what this means is the accumulator method called concurrently on the mutable result container or not? If you don't set the concurrent flag, then the accumulator method will not be called concurrently. And in that case, if you do set concurrent, then the mutable result container must be synchronized. That means that you, the programmer, have indicated you will handle synchronization. So whatever container you give here as the accumulator type needs to be concurrent. So it would have to be something like a concurrent hash map or a concurrent list or a concurrent queue or whatever you're trying to move things into. We're going to focus on non-concurrent collectors right now, so we don't have to worry about the concurrent flag. In fact, we could leave all the flags empty, but for your assignment, I gave you certain things you'll have to do. So watch the video and then read the comments to see what you have to do. Here's a typical way of creating characteristics. So if we want to set all the characteristics, which you might do or might not want to do depending on the semantics of what you're trying to achieve, then you could say enum set of as a factor method, give it a list of the enums, concurrent, unordered, identity finish, and then return that as a so-called unmodifiable set, and that comes back as a set. Unmodifiable set means you just can't make any changes to it once it's set. It's immutable. Okay, so that's characteristics. So that's kind of metadata that's used by the framework to figure out how to do things. The next method we have here is the supplier. And this is a factory method that returns a supplier that will generate the appropriate type of result container, mutable result container, that starts out initially empty. And here's a very simple example. You could have a supplier that returns the constructor reference for array list. So that would basically be a constructor reference, which when called will make us a new instance of array list. So that's a good example of a constructor reference. Accumulator is a factory method that returns a by consumer that knows how to add a new element to the existing, because it was already created by supplier, or by the result that came back from supplier, to the existing mutable result container. So let's assume, for sake of argument, we've got a list. Then list : add is a method reference that describes a by consumer that takes a list and an integer and adds the integer to the list. And of course, the list it's adding to, in this case, will be the one that was created by the supplier. So this is how the streams framework makes the mutable result container, and this is how we say how we're going to add the next item to it, through the accumulator. So these are factory methods. These methods return method references or constructor references which are used by the framework to do the appropriate operation. Keep in mind that a non-concurrent collector needs no synchronization, so it never has to worry about synchronizing anything. The next method is called the combiner. And if you have a parallel stream, then the combiner is used to take the results of one sub-result and take the results of another sub-result and join them into a combined result. So it merges two sub-result containers together. And again, this will make more sense when we talk about parallel streams. We don't really have to worry about that for sequential streams. So what this does, this is actually returning a binary operator lambda expression that takes one list and another list, and it adds another list at the end of one list and returns one list. So it's basically merging these things together. And this is a lambda expression. So this is not actually being performed at this point. This will be performed when the streams framework deems it necessary to merge things back together again. The finisher is this factory method that's used to return a function that knows how to convert the result container to the final result type. So if there's nothing to do, you could return function identity, or you could just set the identity finish characteristic and then just make this a no-op, just say return null, because it's never going to be called. And that's probably the better thing to do, because there's no point in calling this if it's not going to have to do anything. We will talk later, for the stuff that we're doing now, you can do sort of identity finish and not have to worry about it, because we're doing simple things with lists. We'll talk later when we talk about completable futures, much more interesting examples of finishers. And in particular, this completable futures thing does some really cool finishing by using very powerful arbitrary arity operations defined as part of the completable futures framework in order to be able to do all kinds of cool stuff in the background. So we'll talk about that later. Not important right now, but just giving you a overview of what will come, a preview of what will come. If you want to learn more about how to create custom collectors, then you can either wait till next time when we go over the video that covers that, or you can, if you're impatient and want to know now, go ahead and watch this video, which is by a friend of mine named Angelica Longer, and she's an expert on a lot of things. One of them is Java streams and collectors and reduce and so on. This is a really good video, so I recommend you take a look at it if you're interested in knowing more about this kind of stuff. Okay, so that is the end of some examples of how to implement non-concurrent collectors.